Hi, and welcome to our last section of this course, your next data challenges. There are still plenty of models to build on our dataset. In this section, we give you the ideas so that you can develop by yourself awesome analysis. We will talk about user recommendation and graph analytics. Then, I'd like to open your mind and give you directions to go after this course. Now we move on to the first video of this section that deals with user recommendation. In this video, we are going to take a look at collaborative filtering and highlight the limitation we have with our tweet dataset. To overcome this limitation, I will introduce you to the cosine similarity to find similar pairs, and we will apply this technique on the user matrix. Recommendation algorithms are well known to a large public as their results are visible on websites such as Amazon or Twitter. Recommendations can drive important revenue, so there is a large focus on them. The idea is to predict what users would like based on relations between items. Recommendation algorithms attempt to propose content that users don't necessarily know. Spark supports the collaborative filtering algorithms that attempts to fill a user-item association matrix. With our tweet dataset, we have the favorite count attribute on each tweet, and we could think of using this to build a recommendation model. Unfortunately, we don't know which user has favorited the tweet, so we cannot use collaborative filtering. Typically, you would need a dataset with entries such as user item rating, so the details of who favorited the tweet would be available. I'd like to propose here a workaround based on the cosine similarity measure. The idea is to associate close tweets with each other. We could say that similar tweets sent by two different users could drive to a recommendation of user to each other. We must, however, be very careful before sending the recommendation. For example, checking that the user is not already in the friend list or that the similar tweets are not simply retweets. So, cosine similarity is a measure of similarity between vectors that measure the cosine of the angle between them. The very first step is thus to represent a tweet as vector. We should be used to this now. We just have to build a pipeline to create a TF-IDF model and transform text to vectors. We can now combine our feature vectors in a matrix. For this, we have to go from the ML vector representation to the MLlib representation. Then we create a row matrix from the MLlib vectors. The rows represent the tweets and the columns represent the words. So asking the cosine similarity will return similarity between words based on which tweets we find them. To get the similarity between tweets based on their words, we need to build a row matrix where rows are words and columns are tweets. This is basically transposing the matrix. Unfortunately, the row matrix does not provide a method for this. To transpose, we have to create a coordinate matrix from our vectors. Call the transpose method and then convert it to a row matrix via the toRow matrix method. Now we can call the column similarities method and get a matrix of all the cosine similarities. We have two options here to compute the similarity: the brute force or the estimation with dim sum. Asking the first row of the matrix will give the indices of the most similar tweets. The Spark column similarity implements the dim sum cosine similarity algorithm, which has a complexity of O(n) exponent 2, n being the number of columns. If you have wide matrices, locality-sensitive hashing (LSH) algorithm would allow you to minimize the shuffling. LSH buckets similar rows into k numbers of bins which are then compiled in parallel. In this video, we have gone through the techniques to find similar users.